Hello grade 12s, welcome to today's lesson. We are going to be jumping into financial mathematics, this really lovely chapter in our syllabus. Today we're going to be talking about simple and compound interest, straight line and reducing balance depreciation, how to work with inflation rates, nominal and effective interest, as well as timelines. Let's get stuck in. So let's start off with these really simple and basic concepts of, simple and compound interest. So here I've written down the formulae that we use for both. So for simple interest, we use the formula A equals P, 1 plus I times N. And for compound interest, we use the formula A equals P, 1 plus I to the power of N. So we obviously see the glaring difference is the position of n. N in the exponents versus here where n is in the brackets multiplied onto I. And just to discuss what each of the letters represent, A is your future amount, your future value or the accumulated amount. P is your principal amount, or I like to think of it as at present, today. How much am I investing? Or how much am I borrowing? I is your interest rate written as a decimal. So you are given the interest rate as a percentage, right? As a rate. We are going to change that rate into a decimal by dividing through by 100. And N, your time period in years, is then the last variable that we deal with. So what is simple interest? If interest is calculated at the end of each year using the original amount of money saved or borrowed, then it is called simple interest. All right, so simple interest is that you are earning the exact same amount every year. The interest is constant. And here I've represented it with this nice linear line. Every year, your interest stays exactly the same. It's not going to change. Now, with compound interest, and I mean, check out this graph, right? Compound interest is if the interest is calculated on the original sum plus interest already earned. That is when it will be compound interest. So you're earning interest on top of interest, and that's why this growth we can see is so big. The interest or growth on your money is reinvested back into your investment or back into the loan. And this, in this sense, money makes money. By keeping your debts to a minimum and rather concentrating on investing your money wisely, grade 12s, you can harness the power of compound interest and become more financially independent or even wealthy. In fact, Einstein called compound interest the most powerful principle in the universe. Isn't that interesting? So this is all good and well, but let's put this into practice. I'm going to show you how easy it is to use these formulae. So here's our first example. Alice and Finn are deciding how to invest 5,000 Rand. Alice's bank offers her a simple interest rate of 5.5%. So here's this PA. So PA means per annum. So once a year, she's earning 5.5% simple interest over 10 years. Finn gets offered a compound interest rate of 5.5% over the same time period. Who will have the most money in their savings after 10 years? So I chose this graph as well because we can see that maybe this is around 5,000 Rand, right? We can see over the first 10 years how the investments are looking very similar. But it's really after that that we see the projection is so much higher for Finn's investment versus Alice's investment. Okay, now let's see how would I figure out though who has what after 10 years. So let's start off with Miss Alice. So Alice, she had 5,000 Rand to invest. So A equals P, her principal amount, what she initially put into the bank. 1 plus. All right, so remember I said now that your interest rate is written as a decimal. So what you do is you take this 5.5, right? 5.5, and you simply divide by 100. So we're going to change that rate into a decimal. All right, and this happened over 10 years. So remember that with simple interest, it's that you're going to be earning the exact same amount of interest every year. It's not going to grow over time. Obviously the accumulated amount will grow over time, but the interest will remain the same. So into my calculator, I just plug this in. 5,000 times 1 plus 0,055 times 10. So after 10 years, she will have in rands 7,750. All right. So that's not too bad going. Let's compare this to Finn. So Finn's investment was compounded. So we are earning interest on top of interest, and we are expecting him to have more money compared to Alice. Maybe not that much more because of the time period, but definitely still probably a little bit more. Let's see. So into my calculator, I sub this in. Right, but now my n is sitting in the exponent. So I get that Finn will have 8,540 Rand and 72 cents. So you might say, yeah, I mean, that's really not that much difference, right? Less than 1,000 Rand difference. But if their investment was, let's say, over 50 years, I would definitely rather be in Finn's shoes, right? He's earning way more money. Okay, and this really illustrates the power of compound interest and how quickly that money can grow. So we obviously want to invest using compound interest. That is amazing. And if we were taking out loans, we would love it if it was using simple interest. But unfortunately, the banks use compound interest. But yeah, those are your two formulae. Really nice and easy, super straightforward. So we need to discuss different compounding periods, right? Because it's a little bit unrealistic to think that if you take out a loan, that the bank would want you to pay back your loan only once a year. Or imagine you invested money and you were told, okay, you're only going to earn once per year. We just saw in the previous example, especially with the straight line, how slow that growth is. So I would say, no way, Jose, I don't want to earn money per annum just once a year annually. I want to earn more often than that. So this is what we're going to explore, that interest is not always calculated annually, but is often based on different time period, such as monthly, quarterly, semi-annually, or even daily. So here I've shown you how we adjust the compound interest formula. So it's exactly the same as what we've looked at, just that I've introduced this variable m, right, where m is going to represent how often you are earning interest. So when you're earning interest daily, m is 365, right, for your 365 days a year. Right, don't overthink it with leap years and stuff like that, right? If we say daily, it will be 365. Monthly, so you are earning interest 12 times a year because you are earning interest every month. When we earn interest quarterly, so you'll earn every 3 months basically, right? Because if you divide up a year by 4, it happens every 3 months. But in a full year, you would earn interest 4 times a year. So be careful, quarterly is 4, not 3. Semi-annually is every 6 months you are earning interest, but you don't say that m equals 6, right? 6 goes into 12 twice. So every 6 months you are earning interest, but that only happens twice a year. Okay, so don't get muddled up with these ones. You earn interest 4 times a year, every 3 months. You earn interest twice a year, every 6 months. Okay, so here's our second example. Kale invests 50,000 Rand at 8% per annum compound interest. What will his money grow to in 5 years' time if interest is compounded? So we're going to look at monthly, quarterly, semi-annually, and daily. And grade 12s, what do you expect to happen? as I go from monthly, quarterly, semi-annually, daily, will my money get bigger or will it stay around about the same? Let's see what happens. We are again going to explore the power of compound interest. So monthly, A equals P, our principal amount of 50,000 Rand. 1 plus. All right, we need to change our rates into a decimal. So remember, this is super basic. We just take that 8%, we divide it by 100, and we left with our R value of 0,08. So if we were earning interest just once a year per annum, this is how I would leave my question right now. But we are now compounding monthly. So we need to split up that 8% over the 12 months. And you should realize now that I must also then multiply the number of years I'm investing for by 12, right? Because, so what does this actually total to? This is 60, right? So you are going to be earning interest 60 times over that 5-year period, right? Which makes sense. You're earning every month, right? So in 1 year, 12 times, but over 5 years, 60 times. Okay, so this is how we make the adjustment in our compound interest formula. Now, again, we just plug this into our calculator and we get an answer of, so at the end of 5 years, Kale will have in rands 74,492 Rand and 29 cents. Okay, so let's see what happens when I do this quarterly. All right, so same principal amount of 50,000. The interest rate is 0,08, right, over 5 years, but now quarterly. So 4 times a year, you're earning interest. All right, so over 5 years, you would earn interest 20 times. So I have this all punched into my calculator already. I'm just going to change my 60 to 20 and my 12 in the denominator to 4. And this will now be, so after 5 years, if he compounds quarterly, we should be expecting a smaller amount of money because he's not earning as often. Let's see what he gets. 74,297 Rand and 37 cents. Okay, so we're quite close in amounts, right? But remember that this is only over 5 years. Think back to that graph. It's only really after 10 years that we see that big growth difference. And also, we're just comparing it to a very small time period. So we're not going to see too much of a difference here. All right, so number 3, we did it, or we earn interest semi-annually or biannually. So it's 0,08 to the power of 5. But remember, it's not now once a year. It's twice a year. So you would earn interest 10 times over the 5-year period. So seeing we just sub this into our calculator. So 50,000 times 1 plus 0,08 over 2 to the power of 10. If he did it semi-annually, 74,012 Rand and 21 cents. So we can still see how the amounts are decreasing the less often I compound. Okay, we just have one more to look at if we had to do this daily. So if we do this daily, again, same formula. A equals P, my principal amount of 50,000 Rand. My interest rate was 8%. It was going for 5 years. But now I'm earning interest every day. So I divide by 365 and I would multiply by 365. So I'm pretty sure that this fourth amount is obviously going to be the biggest amount because I'm earning interest so often. So I just plug it into my calculator. What do I get? 74,000 Rand, 587 Rand and 97 cents. Okay, so here we've shown in this little quick exercise that if we are earning interest more often, we are obviously expecting to get a bigger amount of money. And the way that we cater for these new change in how often we are compounding our interest, you simply make the adjustment here with this variable m. I'm now going to talk to the topic of nominal and effective interest, which is really quite interesting, and that's why I have these tables up here, because we've been talking about how we can compound half yearly, semi-annually, biannually, twice a year, quarterly, monthly, right? I forgot to mention weekly in our previous slide, but if you compound weekly, 52 weeks in the year, and daily. So nominal and effective interest it's now taking into account the fact that you are earning interest more than once a year. And let's explore what happens in these tables. So I've figured out with my changing compounding periods, right, from quarterly, monthly, weekly, daily, I've written down what would happen to 1,000 Rand if it was growing at 8% over a year for these different compounding periods. So we can see the amounts are quite close together, right? But we are expecting the increase over time as I'm going from compounding semi-annually to the most often compounding every day of the year. We are obviously earning more money. So this is the interest that would have been earned on top of the principal amount, 1,000. So now if we focus on and look at this second table, so covering up this first table, we don't really need it because here's all the information that I must focus on. This is what's really important. Look at what's happening over time. All right, so from our compounding half yearly, quarterly, monthly, weekly, daily, here they've shown you how to solve for I using your compound interest formula. So this is A equals P, 1 plus I. This is happening over just 1 year. So your N is just 1, all right? So your accumulated amount, what you have at the end, is what you would sub into A. The principal amount, the initial investment was 1,000, 1 plus I to the power of 1. So here we're dividing both sides by 1,000, subtracting 1 from both sides, and we get that I is 0,0816. To change this into a rate, so remember, we would usually take the rate and divide by 100 to get to a decimal. Now I'm going to take the decimal and times it by 100 to make it a percentage. Okay, so I'm just going to do that now for the next 4 lines, the next 4 rows. So when it's quarterly, we see that the effective interest rate is 8,24. When it's monthly, so if I look at all these decimals, that will become 8,30 if I then round off to 2 decimal places. Right, these are all rates, so as a percentage. Here, it will be 8,32%, and here it will be 8,33%, rounding off to 2 decimals. So isn't this quite curious and interesting? Because if we now do have a look back at the first table, the percentage, the rate that we were given was 8%. Throughout the initial calculations that we did over here, right, we were working with 8% per annum. And now, look at this table though. I mean, they're close to 8%. They're very close to 8%, but they are more than 8%. So what we are noticing here is this is the difference between nominal and effective interest rates. So I like to think of the nominal rate as the rate which is quoted, let's say, by the bank or whatever financial institution that you're working with, right? They'll say to you, okay, we're going to invest your money. We're going to give you a rate of 8% over however many years. So that we would call the nominal rate. The effective rate then is taking into account the fact that you are not only earning interest once a year, but maybe twice a year, 4 times, 12 times with monthly, 52 times, 365 times a year. All right, so effective interest rate takes into consideration you're earning more than once a year, your nominal rate would be the quoted amount. Okay, so why have I shown you all of this? Because we're going to ask you problems around nominal effective interest. And this is the formula that we use. We have that 1 plus, so we say I effective, right? So the effective interest rate is equal to 1 plus the nominal interest rate divided by however many times you are compounding, and we raise it to that same value. Okay, so this formula here allows us to switch between nominal rates and effective rates. So a question might be, given the nominal rate of 8%, calculate the effective interest rate if your money is compounded quarterly. So let's just see if our table is correct. Let's put this into practice. So my question was, we're going to find out the effective rate if the nominal rate, the rate which is quoted to me by the bank, is compounded quarterly. All right. So we're just going to solve, it's like solving for x, right? We're just going to make this the subject of the formula. So your effective rate will be the nominal rate, 1 plus 0,08 compounded quarterly. Right, we subtract 1 from each side, and what we're going to do is we just punch this into our calculator. Let's see what we get. We get, this is 0,0824, and I multiply that by 100 to get to the effective rate. It's 8,24%. And hey presto, what did we figure out in our table? Yay. Okay, so that's the difference between nominal and effective interest rates. I think I think of the nominal rate as like the quoted amount, right? And the effective rate takes your compounding into consideration. And you should realize as well that which one do you think will be the bigger value always? Okay, it's also just important to remember, just make a note for yourself that, oh my, there's so much going on here. Your nominal rate, right, the nominal rate will always be a smaller amount compared to the effective rate. Okay, so yeah, that's nominal and effective interest rates. Interesting, hey? Our next topic of discussion is depreciation, and I'm sure many of you know what this means. But just in brief, it's how certain assets or possessions lose value over time, right? Because of general wear and tear, right? And because of use of the equipment that you're using, or for instance, a good example would really be a car, right? A car, we know, as soon as it leaves the showroom, it's already lost a whole bunch of money, right? It's already gone down in value as soon as it's out of those doors. So we have two different formula that we work with to figure out depreciation on items, equipment, cars, etc. Our two different methods of depreciation. We have the straight line method, A equals P, 1 minus I times N, and reducing balance, A equals P, 1 minus I to the power of N. And some of you might be looking at these two formulae and thinking, well, these are really familiar. And you would be right. This is so similar to the simple interest formula, right? Remember that simple interest was A equals P, 1 plus I times N. So what has happened is we've just simply replaced the plus with a minus. And reducing balance, that looks awfully simple or similar to the compound interest formula. And you would be correct. Because what was our compound interest formula, grade 12s? A equals P, 1 plus I to the power of N. So what's changed? That positive has just become a negative. All right. So I remember simple interest is for straight line depreciation. They both start with S's. And if you can remember the one, well, we can obviously then remember our second formula. Okay, so reducing balance associate with the compound interest formula, straight line with our simple interest formula. Okay, pretty nifty, huh? But so you might be thinking like, but why is there this association and relationship? Well, the way that these two types of depreciation work, the graphs are very similar to the graphs we see in our simple and compound interest formulae as well. So just that they're obviously working now in the opposite direction, right? We are losing value. So in simple and compound interest, our A value is usually the bigger value, right? Because you put down your principal amount, that money earns interest, it grows, and then we have the accumulated amount at the end, which is more. In depreciation, this is the other way around. Your principal amount is the bigger one, right? Your principal amount is bigger than your accumulated amount because it's losing value over time. Whereas with simple and compound interest, your accumulated amount, A, will be greater than P. Okay, so that's very important that you remember that. Let's get stuck into an example to show you just how these formulae work. So here's our example. Jacob buys a car costing 120,000 Rand. Lucky fish. He wants to determine the value of the car after 10 years. If it depreciates at 8.25% per annum, how much will the car be worth if it depreciates by a straight line method, a reducing balance method? So it's important to note, grade 12s, that you only your item will only lose value once a year when you're using these depreciation formulae. You don't have to worry about compounding, let's say monthly, quarterly, semi-annually. You don't have to take that into consideration. This will always just happen once a year. Okay, so our important information is that's what it costs. That's going to be your principal amount. This will be your N value, your 8.25. We're going to convert into a decimal. So let's see what happens. So with the straight line method, which is like the simple interest formula, we just replace that plus with a minus. So 120,000, 1 minus. So that will become 0.0825, and we're going to multiply that by the 10 years. Now, you want that A value to be smaller, right? The amount at the end must be less than what the car initially cost. We just punch it into our calculator. Oh my goodness, it's only worth 21,000 Rand after 10 years. Okay, and just remember that as with the simple interest formula, straight line depreciation, it's losing the exact same amount in value every year. That is fixed. It will be different, however, when we are doing reducing balance, because the interaction is exactly the same as with the compound interest formula. That interest on top of interest is being lost here. So A equals principal amount of 120,000, 1 minus 0.0825. Remember what I'm doing? I'm taking that rate and dividing it by 100. So I just jam this into my calculator, right, to the power of 10. Remember, like the compound interest formula, just replace that plus with a minus. And that's going to be worth 50,000 Rand, 727.33, rounded off to 2 decimal places. So we see that with the straight line method, you should realize that this is going to get to a point where it has no value. We're going to start getting to negative rands, right? After just a couple of years, after 10 years. So when you're using a straight line method, your item, your piece of equipment, whatever, can get to the point where it's worth 0 Rand. With reducing balance method, however, there will always be some money left over, right? And the car would work with a reducing balance, because a car is still something that you could sell for scrap, right? You could sell it for scrap metal. It's never going to be worth nothing. So if I just quickly show you what the graphs of those two things would look like. So if you're losing value on an item, with straight line depreciation, oops, now it's purple. All right, this is what will happen. So let's say it costs 120,000 Rand. It loses value over time. It can eventually get to a point where it is worth 0 Rand. That's what happens with your straight line depreciation. The graph for reducing balance, this is what it would look like. So just have in your mind, think about what that compound interest graph looked like. So reducing balance is that it starts off with an amount of money and then it curves like this, right? But it's never going to get to a point where it's worth 0 Rand, right? It's going to have some value over time. We can sell it for scrap metal, salvage something out of it, but it will be worth something. Okay, so yeah, that's your depreciation formula. Super easy, right? Let's move on. So let's discuss the juicy topic of inflation, the scary topic. Jokes, is not so scary. But here alongside, I actually have what the inflation percentage has been doing in South Africa from the year 2014 up until now. So I actually have a more accurate amount now for March. For March 2020, the current inflation rate is at 4.1%, which is awesome because we can see in South Africa we're aiming to have it around 4.5%. Your inflation, the percentage of your inflation is very important because if inflation rises above what people's salary increases are, for instance, then they're obviously going to be losing money every month. Your inflation is incredibly important to a lot of things around your economy. But we're not going to discuss that. We know it's generally how things increase over time. And if I discuss what purchasing value of money means, so if you won R1 million, let's say in the year 2000, you could probably buy a whole bunch more compared to if you had R1 million today. Okay, so that's what purchasing value of money is referring to. So over time, we know stuff goes up in price. That's just how it is. And it's all because of this annoying thing called inflation. But let's get stuck into the example because you don't have to unpack all of that if you're writing a test or an exam. You just need to be able to answer the questions around this. So Zach buys a loaf of bread, which currently costs 9.58 Rand. How much will he pay for a similar loaf of bread in 5 years' time if the inflation rate of 4.1% is maintained? So it's actually super easy. Inflation, which formula do you think it would link up with? Simple interest or compound interest? We definitely know it's going to be compound interest, right? Unfortunately. But yes, when you get your inflation questions, you're just going to literally substitute into your compound interest formula. So we want to know what the bread is after 5 years. So it was 9.58 Rand. The interest rate, remember, you take that 4.1 and you divide it by 100, and our exponent is going to be 5. So when we just punch this into our calculator, we get that the loaf of bread in 5 years' time will cost Zach 11 Rand and 71 cents, right? Which doesn't look so bad because it's a low inflation rate. So you can imagine if the inflation rate gets really high, like over there, how stressful that can be on people and on the economy as well. So we want that inflation rate to stay nice and low. Okay, so grade 12s, what do you need to remember? Inflation, we use the compound interest formula when trying to determine what are the value of our good, our item, equipment, whatever it will be, will cost in the future. So I know straight away you're looking at this slide and thinking, oh my word, there is already so much going on. What on earth is a timeline? So a timeline is something that is going to make our lives simple, grade 12s. It's going to take all of this mess and condense it into this very simplistic diagram. So timelines are useful when dealing with cases where there are changes in the interest rate or when multiple amounts of money is deposited or withdrawn. So this is like real life, right? You make an investment, let's say, and the interest rate changes because a recession happens or a global pandemic happens or whatever. Interest rates generally aren't fixed. They usually fluctuate. And deposits and withdrawals are also super common, as we see now in the example that I made up. Let's have a look. So, Erin opened a bank account on the 1st of January 2016. She made a deposit of 50,000 Rand as she opened the account. So when she opened it, she popped 50,000 Rand in the bank. Lucky her. On the 1st of July, so a year and a half later, she withdraws 15,000 to take Rebecca and Chelsea on holiday. On the 1st of January in 2018, the following year, she deposited 20,000 Rand, which Alex and Hannah gave to her as a birthday present. Isn't that awesome? So yeah, there's been deposits, there's been withdrawals. That's pretty real life, normal stuff. The interest rate was 7% initially, right? Compounded monthly for the first 18 months, and then changed to 8% compounded quarterly. So my compounding period changes and the percentage. How much money was in Erin's account immediately after the 20,000 deposit? So this question is looking freaky, right? There's so much going on. But let me show you how simple we can make this. So we call this timelines because we're going to make a timeline, grade 12. This is going to make our life so easy. Let's just look at the question. It started on the 1st of January 2016. And we're looking at what happened on the 1st of January 2018, just after that 20,000 Rand deposit. So you agree with me, 2 years have passed. So I make labels. I make little notches. T0 represents the start of my timeline, the start of my investment, or the start of my loan, depending on what the question is saying. So T1 will represent 1 year passing. T2, we're looking at how much is she going to have at the end of 2 years. So now, okay, I've set out how much time elapses over this entire investment period. She starts off with 50,000 Rand in the bank. After 18 months, so on the 1st of July 2017, so that would be here, right? Halfway between my year 1 and year 2. At that point, she withdrew money because she took her friends on holiday, right? She withdrew 15,000 Rand. And then because people just saw how awesome she was, at the end, they gave her 20,000 Rand to deposit back into her account. All right, so that timeline now at the moment is illustrating the deposits and withdrawals. But remember, we also need to talk to the changing interest rates. So it says it was 7% compounded monthly for the first 18 months. So that is this area here. So it was from the start of the investment period up until this point where the withdrawal happened, right? Where the interest was. So I actually set it up for myself already. It's the 7%, which I divide by 100. So 0.07. And then I write it as over 12. Just to remind myself that it's compounding monthly for those 18 months. All right, and then we just need to fill in the last bit. So from this point till the end of the investment period, we see that it's going to be, so the question told me it was 8% compounded quarterly. So 0.08 over 4. All right, so grade 12s, this illustration here is really, so this is the timeline bit, and this is what's going to make our life super easy. So now what I'm going to do is, because I've got quite a lot to consider, right? I'm going to focus on the 50,000 Rand earning interest, right, at 7% compounding monthly, and then earning interest for the remaining period. from that, I will subtract 15,000 Rand and the interest that it earns. And then right at the end, I'm going to add 20,000 Rand. So let me show you what I mean. Okay, so I'm going to say my accumulated amount. What I'm going to have at the end, it will be the 50,000 Rand earning interest at 7%, compounded monthly for 18 months. So 18 months we know is 1.5 years, which we times by 12. And if I say 1.5 times 12, well, that is 18 months, or just 18. And now I'm going to focus on, so whatever that amount of money is, right, the 50,000 earning interest for 18 months at 7%, that amount of money will also earn interest set at 8%, but compounded quarterly. And how long was that for? It was for the remainder of the year. There was half the year left, right? And we are compounding quarterly. And 0.5 times 4 would be 2, which is perfect. It's those 2 quarters which are left over. Okay, so that's how we're going to deal with what's happening with the 50,000 Rand. Now, from this, we will subtract 15,000 Rand, right? That withdrawal. But that withdrawal, right, obviously that 15,000 Rand, if it was left in there, it would be earning interest. So we're just going to figure out what was the amount that it would have accumulated to if it did stay. But because it was a withdrawal, we obviously must subtract it from the 50,000 Rand, which has grown over time. So we go, all right, 15,000. The interest rate was 8% compounded quarterly. And that interest happened, it was the exact same period as what we did earlier, the 0.5 half a year compounded quarterly. And then the last thing we just need to do is to add, so I'll zoom everything out back now. The last thing we need to do is to add the 20,000 Rand she got as a prezi from her wonderful friends. Okay, so I know that looks hectic, eh? But this is explaining our picture over there. 50,000 Rand earning interest up until this point at 7% compounded monthly. That amount of money now earns a new interest rate until the end of the year at 8% compounded quarterly. Obviously, there's been a withdrawal. So I must take away the 15,000 Rand. But it's not just 15,000 Rand. Remember that this is now money you've lost potentially. The interest that you could have earned on 15,000 Rand, you've lost. So you can't just say minus 15,000. It's minus 15,000 times the interest rate over that period. And then at the very end, she gets 20,000. So now to answer it, okay, we're just going to punch this into our calculator and let's see what we get. If you want to do it portion by portion, that's also fine, or we can just type it in one go. And simplifying all of that, we get that she will have 62,155 Rand and 54 cents. So good for her. She had more than she started with. And she got to do a couple of fun things as well. Okay, so we'll get to practice timelines more, grade 12. This was just, I know that this was quite a complicated, complex example perhaps, but it really nicely illustrated the effectiveness of timelines to show you changing interest rates, deposits and withdrawals. And I don't know, it's actually just very logical to set it up like this. So I hope you really enjoyed the lesson and that you're thinking that finance is easy peasy, lemon squeezy. And yeah, we'll chat again soon. Thanks, grade 12s.